With traditional target selection-based teleportation, target points are usually restricted to intersection points of a straight ray or parabolic arc with the scene's geometry, not allowing users to select mid-air targets in order to observe points of interest on other elevation levels. To solve this problem, we created SATOR, a 3D teleportation technique that allows users to select mid-air targets while also considering air-to-ground and ground-to-air transitions for seamless, unrestricted navigation. To do so, our technique has two states, a ground and an air mode. For the ground mode, we implemented two types of ground navigation tools, ray and arc. With the ray ground tool, the target point is determined by the intersection point of the ray with the ground geometry. The target location can be moved into the air if the ray does not intersect with ground geometry. The second ground tool is a parabolic arc, allowing users to jump over obstacles or onto small adjacent platforms, and provides better accuracy than the ray. However, transitioning into the air is not as straightforward, as the controller cannot simply be pointed in the air. Instead, a button must be pressed to transition to air mode manually. While this adds complexity, it also allows users to activate the ground mode when in the air, to be able to select targets on the current elevation level. In air mode, targets can be selected via a straight ray cursor that is shown when the trigger button is pressed. To move the cursor along the ray, we implemented two mechanisms. The first mechanism relies on the controller's joystick to move the cursor along the ray. To transition back to the ground, simply move the preview avatar on top of the ground geometry. After teleporting, the ground mode is activated automatically. The second mechanism relies on the tilt of the controller to move the cursor along the ray. Users first have to aim in the intended direction by pressing the trigger button. If the trigger button is fully pressed, the direction is fixed, and the system enters a tilt mode where the cursor can be moved along the ray by tilting the controller up or down. Similar to before, to transition to ground mode, simply place the preview avatar on the ground and initiate the teleport by letting go of the trigger. We tested our technique in a user study where users had to follow a path of cameras. The combination of the two ground tools and two distance control mechanisms led to our 4 SATOR variations: arc and tilt, arc and joystick, ray and tilt, and finally ray and joystick. We also compared our techniques against an existing mid-air target selection technique. In the end, we were able to show that our techniques outperformed the baseline in terms of efficiency, usability, task load, and subjective preference ratings. More information can be found in our paper.